Hello. So we got more questions asked after the yesterday's class. I'm just going to quickly go over what we have done in the past. So you look at this system. So cyclohexane attached to a larger group and mostly like tert butyl group, there would be 99% equatorial and maybe 1% axial because its unstable compound rolls into the flip into the more stable form, right? So that's a typical pattern of this type of questions. So in this question again, I would be thinking just like the third butyl group, some R group makes stable when it is unstable when it is axial. So it should push the flip to the equatorial more stable form. So the more stable has more ratio percentage or more ratio mole ratio. So if you think about that, it's easier to plug into the equilibrium product over reactants. So specifically when you use delta G is minus RTL and K, so you need to calculate the K, that's why, right? In most of these questions, the R value, the Kelvin temperature is given, you plug in and look at the Ln and then get the answer. So slowly try that question and you should get the answer, right? Now look at this type of question. So the reactant go into product, right? And we need to find out heat, whether it's in the exothermic side or is it in the endothermic side. So when you're given T1 and T2 and you're given in this case K1 given actually, the K2 is not given. So we are looking for it. That's what we did 2 days ago, right? So now I'm just trying to explain that to walk you through again to do a similar question. So find the Vant Hoff, so the modified version, plug in the ln K2 over K1 and plug in, finish these brackets first. Use the bed mass, the brackets first. Solve it and plug in joule to mole. The unit should be cancelled properly too. Right? Now the last thing the questions asked about the ln. Here we take the inverse to cancel the ln. So the otherwise inverse is e to the power. So e to the power give you some number and then multiplied by the cross multiplication, that will end up with 4.5. Now let's make sense of the answer. So let's say you heated from 300 to 400 or 450. Your numbers, the KEQ went from 8.5 to 4.5. So it's lowered. So the K value is actually little products and more reactants. That's why K value is lower. In the other side, it's the other way. So that's how you kind of make sense of your answers, right? The other question we had in the previous class is again, you are given the T1, you're given the K1, you're given the T2, you're given the K2, right? In this case, you're looking for delta H, the enthalpy exchange of the reaction. It's the standard actually, right? No, this is not standard because we are using two different temperatures. So you plug in the values the same way, finish the brackets, get the value divided by the R, and then you do the cross multiplication, you're going to get the delta H value. So it's minus delta H each side, minus will cancel out by multiplying. And the other question asked the ln. You should take ln right away here. That's the difference. When you have ln and two numbers, take the ln of those two numbers and finish it there. So this is not something to do the inverse, right? Yes. So you can take the ln in this case because both are numbers. That's the difference, right? Okay, so try again and send me questions by email or send it to one of our folks, and then they'll ask me. Okay, we can move on to the next questions. Similar questions I got, so I'm just going to do the same thing. It perhaps good idea to do same pattern questions, 3 to 5 questions, and you are solid on heading into the exams, right? So this one ended up with these numbers, and then you divide it by 8.3145. That just finish the brackets and divide by the R, right? Yeah. So, and then cross multiplication will basically 2.41 0.38 divided by the 2 to the power minus 5, you will get this number, right? Minus to minus cancels out. So that's that, and convert into kilojoules by dividing 1000, right? Okay. The next question. So I'm going to go to the ln k versus 1 over t first, because the question is based on Vant Hoff, and this is ln k versus 1 over t. This is something sometimes people did not understand. So this is a y is equal to mx plus c. That's the derivative of it. And then c, x-axis is 1 over t. That's x-axis. And the y-axis is ln k. We just put those things, and either we can have three spots and we can three points and we can draw the line, or we can do mathematically, right? You can do graphically, or you can use the math to solve it, right? In this case, the question's given some information, minus 13K kilojoules per mole, and the entropy is given. So you're given the enthalpy standard, you're given the entropy, right? So we're going to be using, so let's get this information here, right? Yeah. So remove the next question away, so we have more space. So 13 times 1000, it gets minus 1300 joules with 13,000 joules per mole. So solve these little things then and there, then bring it here, right? So joules per mole and 298 Kelvin, 8.3145 are constant, and within the brackets, the intercept is 2020 divided by 8.3145. You can actually get the R out. That's another way. But if you're not comfortable with it, just make sure you solve separately, right? Look at the J mole divided by J mole over K and the K here. So J over K mole and J over K moles. You see, you have to see that way. So you at least should do one or two times unit cancellation. See, do I get just a number? Because this should be ending up just a number, right? So they should tally. Okay, now, so we can just do the math here. Maybe, yes. So finish the very end. So it's EC 20.20 divided by 8.314, right? So let's finish this part. Again, simple division, right? Yes. So now you can just add the numbers together and then you get that, right? So that's the ln k. Now 7.67, that's, yeah, that's from the yesterday's class. Let's see. Yes, so now we have, that's the ln k. Now what do you do? Look at the inverse. So inverse to ln cancels out. The other side of the equation, e to the power. That's the difference again. So now k is free. The k value should be here. So you look e to the power of 7.67, right? And so that way you get the value. So that should be something like 2157. So let's jump the decimal one more, rounding up, and then you will get that, right? Okay, the last one, it's also similar question. So what I have, yeah, 4,800 joules per mole when I convert the 4.8 kilojoule times 1000, 4,800 joules per Kelvin. T1 is 298 because it's standard enthalpy, right? And the pressure is 1. We don't care about that. And the T2 is 450 increased heat, and the K1 is 8.5, and K2 we are looking for. It's almost identical to the question we did today, and plug into the Vant Hoff L in K2 over K1 delta H divided by R. And so let's see, yes, that's the, yeah, that's almost similar to the last question. Now, so yeah, 4800, 8.3145, and then your negative signs still stay there. Finish the bracket, 1 over 450, 1 over 298, and finish the bracket, and then move on to the next right? So again, deal with the units, joules over mole, joules over k mole, j mole to j mole cancel. There is k, this k, j mole to j mole to mole, and k to k, all gone. So it should be just numbers, right? Now, um, so let's finish this one. And okay, so few had the questions about the calculator use, right? So I'm trying to get your official calculator onto my computer so I can show you some of the math manipulations. But this one, I'm going to use the Desmos. Desmos is a pretty good calculator for folks using online calculators, right? So look at that one. That's how you want to separate. So if you have a simpler calculator, you should separate these brackets like that, this way. So this one, don't take shortcuts. You're going to easily make a mistake. And even though you're conscious, so that's why we're going to go to this one, Desmos, right? So plug in here. So exactly with the way we wrote it, expanded version with the brackets. So 4200, that's the delta H divided by 8.3145, and then 4 over 1, 450, 1 over 450 minus 1 over 298. See the brackets, right? So the brackets has to be like that. And then also we have minus 4800, not positive. So let's plug in that one too. So that has to be there. And yeah, this has to be taken, take your time, make sure that's brackets, the signs, everything there, right? Now you get this number here, 0.57525. I won't ditch the decimals, keep it for now. And yes, so you have to have all of them though, right? The more decimals better. And now ln k 2 over k1, you see now we have to take out the case, so that's why inverse. If you do inverse each side, that means e to the power. Inverse to ln cancels out, k2 over k1 comes out. Now you have the answer, and then you're going to look for the e to the power, right? So let's see here, it's in the functions actually. Go there. Yes, e to the power, and then yeah, copy paste the answer. Now you go. So we get 1.777, right? Yes, okay, so we get that, and we have the 8.5 for the K1, plug in, cross multiplication, and then you get the K2, just a number. So that's all, okay? All right, any more questions, please make sure, send it to me or to one of our guys, Dan or somebody. We'll explain that again. All right, thank you, good luck.